when you write this formula, I do kind of want your attention now. Okay, when you write this quandary, right, the way you should think about Q is that Q is heat that flows into the gas. So if it flows out of the gas, it's negative, right? So these are all the positive senses of the word, right? This is an increase. Could cause, so the heat flows in, it could just cause an increase in internal energy. When you're thinking about this thing, think of temperature, okay? Right? It's like the temperature with some constant in front of it, right? Okay. I don't know what that constant is, but yeah, it is, right? Actually, there is a formula for it, okay? But we don't learn that formula. And then this is piston moves out. It expands. Yeah? So if the piston moves in, then it's not work done by the system, it's work done on the system. And curiously, your car actually has both things going on, right? There's actually a fiery hot phase where the piston's moving out, right? But there's also a little thing there where the piston moves in, yeah? It actually has to compress the stuff, so it actually slows the car down. And that's why if you use your engine and you don't give it gas, right, it still has to compress all that air, and that's how it slows down, right? That's how it slows your car down, is it's got to do the work to compress it, but it's not getting the energy from the gasoline, right? Okay, so your engine can act as a brake, and that's what Jake brakes are for, like a big semi, right? Okay. So our first one here, all we have to do, let's see, heat flows into the gas, so it's heat and it's in, so which one is it and what sign is it? Is it Q, U, or W? It's Q, and is it positive or negative? It's positive. I believe that, right? So positive 45. Now we just need one more number, so let's see. Into a gas that does 21 joules of work. That's tough. Is it positive? Yeah, because when the piston moves out, it's doing work. It's not work done on it, it's doing work, right? Pushes the choo-choo forward, so that's positive 21, right? Equals blank plus 21. I'm going to guess the money goes here for 24 is the correct answer, right? This has got to go up 24. So basically, 45 joules of heat flowed in, right? But the school district decided to put 24 joules of that into a reserve fund against a rainy day in the future and use 21 joules of it to pay its teachers, right? I'm just a joke. That's like a little joke. Yeah?
A question about combustion and molecules. It's true that combustion is caused by molecules moving so fast, but I was
Combustion's caused by molecules moving so fast.
I heard that's what I heard. Is that true?
It can be caused by that, yeah.
Because if so, I mean, wouldn't there be a point where when the piston goes down, when it's at a certain point, something ignites it? Could it possibly you could do it without having to ignite it?
Indeed, yes. So the question is, yeah, if the pressure gets, the question is if the pressure gets great enough, can it just ignite the mixture? Now, on a diesel engine, this is supposed to happen, right? So it's got an incredible compression. The compression, of course, causes rising of the temperature, right? And then in a diesel engine, what they do is they spray the fuel in there only when it's supposed to go boom, right? In a gasoline car, if it actually ignites spontaneously like that before the spark, this is called knocking, right? And so back in the day, they used to put lead in the gasoline to prevent knocking, right? Now if your car knocks, what you do is you use high octane fuel, which is a little bit more expensive. That's what premium is, right? It's got more of the stable stuff in it so that it isn't as liable to pre-ignite, right? Knocking is very, very bad for your car, so if it is knocking, it's worth the 20 cents extra, believe it or not, for that, you know. It's extremely bad for the explosion to happen while the piston's still moving up. That's what's going on, right? That's a bad thing, right? Okay. Okay, so Bob White, 54 joules flow into the gas. I'm thinking this is, all right. I'm thinking this is, again, heat flowing in. I'm kind of beating you over the head with it, right? That's got to be, doesn't it? Flow into the gas. We don't even say heat, but the only thing that flows is heat, right? It does 67 joules of work. So this guy has got to be 67. Wow, you only got paid $54, right? 54 flowed in, and you did this much work. So what did you have to do? Didn't you have to spend down your reserves a little bit? Good thing you had those reserves, right? I'm not just making fun of the school district, I'm also complimenting them on their foresight here. So how much do we have to spend out of reserves to do that much work? What is it? Negative. I'm unable to do this math. Is it 13, negative 13? Is that right? Yeah, there we go. So the gas actually gets cooler. This is crazy, right? So it does so much work. It's allowed to expand so much. Even though heat flows in, it gets cooler because it's doing so much work. Does that make sense? It's a weird thing. Okay? We'll talk about exactly how it is that a piston can cool off a gas when it expands, right? And then Job Shadow. Yep. He does work on the gas. So this one's really hard, right? He's doing work on the gas. So what does that mean? What's he doing with the piston?
Pushing down.
He's actually pushing in on the piston. So that, although it's work, what sign does it have?
Minus.
It's definitely minus because the piston is moving in and out is positive. So W here is negative 89, right? He compresses it, and the internal energy increases by 52 joules. So that's pretty easy, right? I think that's plus 52, right? Okay, and then, oh my gosh, this is like, that's so hard. That is 30, don't say it, 37. Is it 37? Negative 37? Oh, it is, must be negative 37. So this is crazy. One way to think of this, right, and this is kind of putting it on its head, right, is that 89 joules, you did that much work on it, right? Only 52 is absorbed by the gas's heat, so 37 had to flow out. Yeah? I don't know. It's always good to sort of think about what's going on there. And then today I want to go over PV diagrams. It's a really cool way to talk about this piston here. Okay? But before that, I have the delivery of an immediately. Yeah? Somebody's in trouble.